All right. Right away, we see that symbol again. What's that symbol between RST and SQ? Perpendicular. So hopefully you guys can put a symbol somewhere on your diagram right now that signifies that those two, that the line and the ray are perpendicular to each other. Everybody putting a right angle, specifically at RSQ. No other place is a right angle other than RSQ. It tells me angle RSU measures 89 degrees, so we'll put 89 degrees there. And now I'm looking for some other angle measures. But here is the thing, and this is, I'm going to stress this big time. Everybody see, and justify your answer. Meaning, when you just write down the answer, degree measure, and that's it, not good enough. How did you know it was that number? That's what I want to know from you guys right now. How did you know? What did you do? What did you punch into your calculator and why? So let's start with the measure of RSQ. Okay, everybody take a look. RSQ. What do we have right off the bat? RSQ. 90 degrees. Okay, but prove to me you know that. All right, you guys are going to hate this, but every time you come up with an answer, why? Why? Why did you write down 90? Why didn't you write down 60? Why didn't you write down 180? Why did you write down the number 90? That's what I want to know right now. Why did you write down the number 90? 36, not even close. $27. Why did we write down the number 90?
Because it says perpendicular and RSQ is 90. Perpendicular is 90.
Perpendicular lines form right angles. Okay, right angles add to 90. I'm not looking for something specific. I'm looking for something in general that shows me, hey, I know why that's 90. All right? It does not have to be perpendicular lines form right angles. Could be a bunch of other reasons I'd fully accept. Measure of QST now. Here we go. QST, everybody. QST. QST, what do we have here? QST. What do you got for me? 18, QST. 90 degrees as well. Okay, I'll just take somebody's. I'm not looking for something specific here. How did we know that's 90? How do we know that's 90 degrees? Let's keep it rolling. 6, how do we know that's 90?
Because it's below the right angle RSQ.
Angle 1's below a right angle, but not 90 degrees. Need something more detailed. Okay, RT is 180 because it's a straight line, meaning if that's 90, it also has to be 90 degrees as well. You could, okay, bunch of different things. These are still perpendicular, aren't they? Okay, so perpendicular lines form right angles. Right angles equal 90 degrees. We could also say, what type of angles are these right here? I know they're both right angles. More than adjacent. More than supplementary. Put them together. Linear pairs. And what do we know about linear pairs? They're complementary? They're supplementary. All right, so we could say linear pairs are supplementary. A lot of different ways here, guys. All right, I'll just stick with perpendicular lines form right angles. But Grace, you see why I need a little bit more than just the one below it, because I could draw that picture and that angle's obviously not 90. All right, kids, let's keep this train rolling. What else do I have? Measure of TSU. Okay, TSU. TSU. I like the hands, appreciate it. Trying to hear from some people. 28, TSU. Ooh, 91. That's a little interesting number. Why 91, kids? Where'd that number come from? Why not 80? Why not 2 degrees, huh? Where did that 91 come from? 18, where'd that come from?
The angle RSU and UST are linear pairs, and RSU, the measure of RSU is 89, and 89 plus 91 is 150.
So you're saying those linear pairs up there are what? All right, I like it. Again, I can't stress this enough. I'm not looking for something specific. As long as you get the point across to me, why you wrote down 91. All right, everybody good there? All right, so if you see justify or explain, be ready to explain why you have the answer of 90, 90, 91. All right, because you'll be doing that for homework later on tonight. Any issues, questions, comments, concerns before we go on to some new pink theorems here? Anything you want to ask up here before I add? Because you know how many are going up there today? 4 of them are going up there today. Okay, 4 of them, more angle theorems. Anything you want to ask? Okay. Let's get going. Today's theorems deal with complementary and supplementary. Okay. First one I'd like to show you is complements of the same angle are congruent and how this works. Okay, there they are. All right. Before I get into the actual proof and how this theorem works, I want to show you using actual degree measures. 1 and x are complementary. I'm going to call angle 1 40. Anybody want to tell me what angle x must be? Oh, boy. What's complementary mean? Let's step back and review. They add to 90. So if that's 40, angle x will be 50. Okay. Angle 2 and x are complementary. So x is 50. What's angle 2? So what do I know about angles 1 and 2? They're congruent. They're equal to each other. A big mistake right off the bat with this is a lot of kids see this. 1 and x are complementary. 2 and x are complementary. So they try to say 1 and 2 are complementary because of something of substitution. That doesn't work. Okay. You can only use substitution if they're equal to each other, not complementary. All right. So everyone see that 1 and 2 are not complementary. I just proved to you. What do we know about 1 and 2? They're congruent because 1 and 2, what were we given about 1 and 2? They're both what? To what? X, the same angle. Everyone agrees. 1 and 2 are both complementary to the exact same angle, angle X. If that's the case, those 2 angles are congruent. They're not complementary. They're congruent. All right. So in step 2, the question is this only a 2-step proof? Am I done right here? Okay, well, let me tell you. Do I have complementary angles stated in my proof? Do I have complementary angles stated in my proof? Where are they? Okay, they're given. If they're not, you guys have to tell me they're complementary and why. Remember yesterday doing the right angles? What did you need to state in your proof before you told me they were congruent? That they were right angles. Same thing here. If you want to tell me something about complementary, you got to tell me the angles are complementary before telling me 1 and 2 are congruent. And I have that. It's given. So I can go right to saying angle 1 congruent to angle 2. And it's because of my new theorem, which says what? Complements of the same angle are congruent. Take a look up there, because this is going to start building pretty quickly. Do we see that 1 and 2 are not complementary? Don't try to force a substitution in here anywhere. 1 and 2 are both complementary to which angle? The same angle, x. So that must mean they're congruent to each other if they're complementary to the same angle. Questions? Okay, how is that different than the next one I'm going to put up, which is complements of congruent angles are congruent? Oh, anybody see that one? Okay, what do you got? Let's go. Let's hurry up here. I want to get through this. This is a big time. There's a lot of homework tonight. We don't need hands. Here we go. What do you want for choices? Cube. Shatter. What's the slide? The genie? That's the genie. Curl. Curtains. I'll throw the old star in there. Pinwheel. Slide right. Slide left. Any more here before we vote? Spin. All right, I think we got enough here. Everybody ready? Anybody for slide left? Slide left. Slide right. No slide at all. Pinwheel. Cube. 1, 2, 3, 4, 5, 6, 7 cubes. Shatters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Little genie. Curl. Curtains. Star. Spin. Spin. Okay, everybody ready so we can get going. So it's either it's got to be shatter or it's got to be the Promethean man. Everybody ready? Ooh, pinwheels. Pinwheels. Who had the pinwheels? Who had the pinwheels? Yep, sorry, pinwheels. Going back now, going back. Yep, pinwheel. Pinwheel. Everybody good and ready to go now? Okay, here we go. We will, yep. Keep on driving. AC perpendicular to BE. What can I put up here now? AC perpendicular to BE. Okay, you have right angles, yep. You know that FBE is congruent to EBD. Everyone look at the angles I'm trying to prove congruent. ABF congruent to DBC. Everyone see those angles? ABF congruent to DBC. You know how to do this one already. I'm just going to do it a different way. How else from yesterday could we do this problem? What could I do with the right angle and this angle, the right angle and this angle, the given angles to get to the ones I'm looking for now? What could I do with the two? Subtract. Everyone agrees? Okay, and then I only have the one pair. How do I get the second pair of equal quantities from yesterday's theorem? Whoa. I don't see bisector or midpoint, so halves should be coming up here. Okay, so everybody stop here. You said subtraction, correct? How many pairs of equal quantities do you need to subtract? 2. How many did I give you? Just 1. This one right here. That's the only pair of equal quantities I have. How do you get what's the process in getting the right angles congruent? You first have to tell me what? That they are right angles because of perpendicular lines form right angles. Then tell me what? After you tell me they are right angles, tell me they are congruent to each other. Okay, this is exactly what we did yesterday with the right angles. Everybody good there? And then I could subtract, substitute. Yes? Tell me here if we got to slow down. We all right? Okay. I'm going to do this differently, though. Because this is a right angle, what do these two angles add up to? 90. What do these two angles add up to? 90. So let's think about this real quick. Don't write anything in. Let's say that's 40 and that's 40. What has to be the other two angles? 50 and 50, meaning what about those two angles? They're congruent. This is where this new theorem applies, which says the following. Angles that are complementary to congruent angles are congruent. Let me say that again. What do you know about these two angles? Complementary. What do you know about these two angles? Okay, so angles that are congruent are angles that are complementary to congruent angles are congruent. That's what this one up here says. Complements of congruent angles are congruent. Now, hey, look at the difference from the last theorem. Are these two complementary to the same angle? No. Do you see how they're complementary to the different angles? That's why I am not going to use that one. I cannot. Do we see that? That these two angles I'm trying to prove congruent are not complementary to the same angle, but they are complementary to what? Well, different angles, which happen to be congruent. All right, see the difference in the two theorems. Okay, now how do I write this all up? First thing is, if you want to use any theorem involving complementary, you got to tell me you have complementary angles. Did I give that to you this time? No, so we got to write it in step 2 that they're complementary. Before we write they're complementary, what's your reason going to be that they're complementary? I want to make a plan. I just don't want to start writing stuff down because you never know where it goes. How do I know these two angles are complementary? They form a right angle? But did I tell you there's a right angle there? Do you see? Oh, okay, all right. Do you see what I'm getting at? That in step 2, you can't tell me they're complementary because your reason's not there yet. You're going to tell me they add to 90. There's a right angle there. But do you have that in your statements or reasons? No, so we have to put these are what first? Right angles. So here we go. Angle EBC and angle EBA are right angles. Why are they right angles? Whoa, watch your mouth. 7, why are they right angles? There you go. Okay, now you guys got right angles. Okay, because when you're telling me they're complementary, everyone's shouting out 90, right angles. They add to 90, the angles, right angles, right angles. Well, you never had any to begin with, so you needed to write it down. Now what can I tell you about those angles? What can I tell you about these two and these two? They're complementary. So name a pair of angles that are complementary now in your diagram. 21, name a pair. Okay, hold on. Angles EBD and angle DBC are complementary. And you guys can, I'm just going to abbreviate it COMP. And what about another pair up here that are complementary? Here you go, 17, another pair. Angle FBE and angle FBA are complementary. Yep. Pretty flexible with this reason here. As long as you mention 90 degrees or right angles, it's up to you. All right, so let me just take it from somebody. Reason why they're complementary. 25, go right ahead. Reason why they're complementary. Okay, they add to 90. They form a right angle. Okay, that's complementary angles. I'm going to write complementary angles. Add to 90. They form a right angle. That's fine too. Okay, so let's finish this up here. Real quickly, a review. FBE and EBD. What did you guys know about them at the beginning? Angle EBD and angle FBE. What did you know about them at the beginning? They were congruent. So anything complementary to them will also be congruent. So angle ABF, congruent to angle DBC. Complements of, what am I going to write here? The same angle or congruent angles? Perfect. Complements of congruent angles are congruent. And again, I want to keep stressing this. You could have done the whole subtraction thing. All right, so if you get this type of problem on homework tonight, you choose. Do you want to use subtraction or do you want to use complements of congruent angles? That's up to you. I'm never going to force you to do a proof one way or the other. Any questions, comments, or concerns? Because now, all I'm going to do, I said I was going to give you 4 today, and I've only given you 2. I'm going to give you the same two theorems, except instead of complements, I'm going to write in supplements. Okay, they work the same way. Now they add to 180 instead of 90. All right, so let's take a look at a supplement one. Page scroll. Ready? Oh, we got to set this one up. ABD is a straight ray, perfect. Angle 1 supplementary to 3. Angle 2 supplementary to 3. Oh, prove 1's congruent to 2. All right, got it. So let's set up our givens and we'll talk. Ready to go? All right. Obviously, I see the word supplementary in my given, so my thoughts are automatically something that has to do with the supplementary theorems that I have. Okay, let's read the givens. 1 is supplementary to 3, and 2 is supplementary to 3. I know, again, I'm trying to get you out of this mindset. Some of you may look at that and say, oh, 1 and 2 must be supplementary then. Just because you do some type of substitution in your head, that's not true. That is not true. Guys, what do you know about angles 1 and angle 2 right now? They're congruent? They're not congruent yet. We're trying to prove they're congruent. They're not congruent yet. What do I know about angles 1 and 2? They're both supplementary to 3, the same angle. And if two angles are supplementary to the same angle, what do I know about those two? Those two are congruent. Okay, two angles supplementary to the same angle. In this case, angle 3 are congruent. Now here's the, do you think this is a two-step? Or do I need to add something else in before I go? You guys are using a supplementary fact, correct? Did I tell you the angles were supplementary? Where? Okay, then you don't need to tell me. All right, so we can just go right to angle 1, congruent to angle 2. And again, which theorem do I want to use here? To the same angle or to congruent angles here? 5, which theorem do I want to use? Yep, supplements. No I, kids, no I. Supplements of the same angle are congruent. If you use a supplementary angle fact, you got to tell me the angles are supplementary if that's not given. If you want to use complementary, you got to tell me the angles are complementary and why if it's not given. Okay, questions? I am going to start. You got some homework to get done here, but I'm going to do a couple here with you, all right? You're welcome. Go to number, I'm not too sure what page, number 4. Where's this located here? Number 4 on page, maybe it's not number 4 anymore. 22, yep. Go to number 4 on page 22. Because this is the first time you're going to encounter this, and I don't want you to start yelling at me. This is what you always told me. Okay, so first thing, this is not in our traditional setup. Some of you may get freaked out. You don't see givens and proofs. Okay, instead you see an if-then statement. Anybody science classes with the, what was it, hypothesis and? That's about it. Okay. Sometimes you may not have the old given and prove. Instead, it'll say, if this happens, prove that this happens. So anything after your if are your what? That's another name for my givens, yep. And then after the then, or in this case, prove that, that's your prove statement. Okay, so please don't be freaked out if it's in an if-then form. Okay, mark your diagram. AB is congruent to DE. Got it. I need to get AC congruent to CE. Yikes. Here's why I want to do this one with you. What key vocabulary term is in the givens? Midpoint. And what we've been discussing is, okay, I see midpoint. It's probably it's definitely a halves of equal quantities proof. I got news for you. It's not on this one. It's not a halves of equal quantities. You've been telling us all week, if you see bisector, midpoint, it's halves of equal quantities, which is true. So I guess we have to narrow that down now, don't we? All the proofs we used halves of equal quantities. How many quantities were we taking a half of? 2, always 2. It was 2 angles we're cutting in half. It was 2 segments we were cutting in half. Everybody agree? But now, how many segments am I cutting in half? Only one, and that is segment BD. Can I use halves of equal quantities if I'm only cutting 1 in half? Everybody, can I use halves of equal quantities if I'm only cutting 1 in half? No, you got to be cutting 2 in half to use halves of equal quantities. All right, so how do I still use this given? Well, you tell me. If C is the midpoint of BD, which 2 segments are congruent up there? BC and CD, yeah. BC and CD, and I could put that in number 2. How do I know they're congruent? Definition of a midpoint. So we had to narrow that requirement down a little bit. You need to be cutting 2 angles or 2 segments in half, not 1, to use halves of equal quantities. And then let's finish this off. How are you going to do these 2 to get to AC? What are you doing to these 2 to get to CE? Don't say a word. Here you go, 18. What am I going to do with these 2 to get to AC and these 2 to get to CE? Add them together. Perfect. How many quantities do I need to add? 2. How many do I have up here? I have the 2. You needed the definition of midpoint before you added, though. All right, so I have AB plus BC equals CD plus DE, addition. And then every addition, subtraction proof always ends with what? Substitution. That's not changing, guys. Never this year. Just say AC congruent to CE. Ooh, that was a little tricky. Everyone all right? You need to be cutting 2 angles or 2 segments in half. I'm going to start one more with you here, but everyone all right on 4? Any questions? Okay. I want you to compare this one to the next one I'm going to do with you, which is 5. Go ahead, just flip the page over for 5. What's the little difference here now? Anybody see anything in your givens? Midpoint, right? Now, how many segments am I cutting in half? 2. So what type of proof is this going to be now? Halves of equal quantities, yes. So you need to tell me the half statements, and then you can use halves of equal quantities at the end. Guys, do you see the difference between the 2? See the difference between the 2? If you're only cutting 1 in half like we were in number 4, I can't use halves of equal quantities. But in number 5, I'm cutting WY and ZX in half. So I can use halves of equal quantities at the end. Okay, you guys can get going on any of the homework. I'll come around, help you guys out. You need a little kickstart. You got a lot of theorems to go with.